Copernicus, the Sun-Centered Answer Part 2. The Sun-Centered Answer, Copernicus's answer was simple. Put the Sun at the center, not Earth. Around it, in order, he placed Mercury, Venus, Earth with its moon, Mars, Jupiter and Saturn. He first sketched this in a short private manuscript around 1510, called the Commentariolus. It circulated only among friends and was never formally published. The model did something the old one never managed. It correctly ordered the planets by their actual distance from the center, using each one's orbital period as the measuring stick. Mercury was fast and close. Saturn was slow and far. Ptolemy's Earth-centered system offered no natural way to derive the planet's order from the center. It had to be assumed, not derived. Copernicus's system pinned that order down as a direct consequence of the geometry. Using trigonometry, he went further still and calculated the relative distances of each planet from the Sun, scaled against Earth's own distance. He didn't know the true size of that baseline distance, so his absolute numbers were wrong. But many of the relative proportions between the planets were remarkably close to modern measurements, despite the limitations of his observations. It was a real, testable result, not just a tidier picture. The new arrangement also solved a stubborn visual puzzle instantly. Mars, tracked over months, appears to loop backward across the sky, a movement called retrograde motion. Under the old model, this required extra circles to reproduce the effect. Under Copernicus's model, it needed nothing extra at all. Earth, moving faster on a smaller inner orbit, simply overtakes Mars, the way a faster car passes a slower one on a highway. The backward loop is simply the changing angle of that overtaking. Day and night stopped being the whole universe spinning around a fixed Earth. Instead, they became the result of Earth quietly rotating on its own axis once every day. A slower third motion was introduced to account for the known drift of the equinoxes. For decades, the full theory stayed unpublished. It took a visit from a young mathematician, Georg Joachim Rheticus, in 1539, to change that. Rheticus studied under Copernicus, wrote a preview called the Narratio Prima in 1540, and pushed for the complete work to finally reach print. It did. In 1543, De Revolutionibus Orbium Coelestium was published. It was the same year Copernicus died.